All right, so this is the third video for convergence and divergence test, and this one's going to be relatively short because we ended the second video with determining interval of radius and interval of convergence for a geometric series that had a variable x in it. So this is just a follow-up example, and I actually want you very quickly to just pause the video and see how far you can get it on your own, and then we'll come back together and I'm going to continue to kind of talk through it. But I suggest right now that you pause the video and do as much as you can on your own and then come back and listen to me talk through it. So I'm going to begin by figuring out what my a sub n plus 1th term would be. And so that would be x minus 5 to the n plus 1 over n plus 1 times n plus 1 plus 1. So that would be an n plus 2. And then a sub n is just my formula that is inside my sigma notation there. So that makes my common ratio the absolute value of x minus 5 to the n plus 1 over n plus 1 times n plus 2, and then times the reciprocal of a sub n, so that would be n times n plus 1 over x minus 5 to the n. So then in terms of breaking things apart, the x terms are similar. So I'm going to group them together, but then everything else is some form of n. So I'm going to group all of those together. And in doing that, hopefully you recognize that these two things immediately cancel out, and this actually becomes just an x minus 5 to the first. So our common ratio then is the absolute value of x minus 5 times n over n plus 2. So then we want to do the limit as n goes to infinity of that expression. Now, when we're doing these limits, we're not focused so much on the fact that x is a variable as we are that n is a variable, because n is what we're wanting to approach infinity. So if n was to approach infinity, then we would do n behavior model with this portion. And x minus 5 you would kind of think of as like the coefficient in front of that n there in the numerator, so it doesn't really go away. So this that I just highlighted there, though, that limit as n goes to infinity is 1. So this ends up just being the absolute value of x minus 5. So that's your common ratio then as n goes to infinity. And so that is what we want to be less than 1. So then we set up our compound inequality with x minus 5 between -1 and +1. So then to get the x by itself, we would add 5. So that means we add 5 both here and here. So that becomes 4 is less than x is less than 6. So remember now at this point, we want to check our endpoints to see if they would create a series that would converge or diverge now. So I'm going to start with x equals 4. If x was to equal 4, then my formula would be the sum from n equals 1 to infinity of 4 minus 5 to the n over n times n plus 1. Or, simplifying that, the sum from n equals 1 to infinity of -1 to the n over n times n plus 1. So I'm going to write out the first two terms of that series. If I substitute in my beginning n value of 1, then I would get -1 to the 1 is -1 over 1 times 2, so 1/2. If I substitute 2 in, then -1 squared is a +1 over 2 times 3 would give me 6. So my common ratio, the absolute value of it, would be 1/6 divided by -1/2, or 1/6 times -2 over 1, and we would end up with a common ratio of 1/3, which is less than 1. Therefore, we need to keep that endpoint. And then if we do the same thing with the other endpoint of x equals 6, we would have the sum from n equals 1 to infinity of 6 minus 5 to the n over n times n plus 1. Or the sum from n equals 1 to infinity of 1 to the n. But let's be honest, 1 to anything is just 1 over n times n plus 1. So the first two terms of that series would be 1 over 1 times 2, so 1/2, plus 1 over 2 times 3, so that's 1/6. So that common ratio would be the absolute value of 1/6 divided by 1/2, which we already learned from the previous one above, would give me 1/3, which is less than 1. So this guy would also give us a geometric series that converges. So going back to my problem, I now need to include 4 and 6 in my interval of convergence. So my interval of convergence would be 4 to 6 inclusively, so I could use brackets. And then my radius of convergence would be end minus beginning divided by 2. So it is 1. And that wraps up radius and interval of convergence. I hope you got lots of paper handy for those problems.